Hello, how are you? Thank you for being here. All right, so today, well, this whole week, we're going to be reviewing for your exam. Let's start talking about your exam. So your exam will be two parts. It'll be your final exam. Your first part will be a multiple choice, and it'll be similar to your midterm, our test that we just took. And then we're going to also have a part two, which will be an open response. Your open response will be 5 questions. And these 5 questions, 2 of those will be a math problem that I'm asking you to solve. I think one of them for sure will be solved using matrices, just because I know it's challenging and I want to make sure I challenge you for your exam, for your final. And then the last 3 will be open response questions that are for you to answer. Questions might be something like, what was the most challenging topic you learned? What did you enjoy the most? Something along those lines. And that'll be your final. So I hope to review today on Wednesday. And then I hope Wednesday evening to have your final open so that you can go ahead and start working on it if you like. Wednesday, and it'll be open all the way until, I hope to do Thursday. Last time I had an assignment that was trying to set the due date for Thursday of finals week and it wasn't letting me post. So that's what I'm saying, maybe Thursday. I want to do Thursday, but if Canada doesn't let me, then I'll have no choice but to have another due date. But I hope to open it this Wednesday. So in case you want to get this done with, so you can work on your other classes, I understand you have other finals, you can work at whatever pace is best for you. Or maybe leave this final at the end, work with the other ones, whatever works best for you. All right, so to begin, are there any homework questions? Now, all of your homework is open until that Monday of finals week. So every homework assignment from quarantine till post spring break until now has been open, along with every quiz that we've had has been open and is open. So there's chapter 4 homework, 5, 6, 7. Is there any homework questions you would like to work on or ask help on?
Could you do number 6 on 6.3?
6.3, yeah. Let's go ahead and take a look at that. I'm going to go ahead and share. And to begin, I'm going to mute all of you, but if you have any questions, just make sure to unmute yourself.
Can we also do number 4 on 6.3?
All right. 6.3, number 4. And what was that first one?
Yeah, look.
On number 6?
Read this.
On 6.3?
Yeah.
Okay, let's take a look at those. I'm going to mute all of you, but again, unmute yourself if you have questions.
What does it say?
All right, so you should be seeing my screen. Let me go back. Homework 6. Six, 3. Here we are, 6.3, number 4. So we want to solve using matrices. Okay, so let's remember what we want. What we want to have is 1, 0, 0, 1, and then numbers. The numbers we have don't really matter, but we need to make sure we have that 1, 0, 0, 1. Okay, let's write our equations as a matrix. So if we write them as a matrix, we have our x's, our coefficient for our x's are 1 and 5. Our coefficients for our y's are -1, -5. And our constants, the equal to number is 11 and 2. Okay, let's go ahead and do some raw operations to solve. So what are we allowed to do? Let's remember what's allowed. Your rules. Your rules are 1, you can switch rows. Yeah. You can switch them. 2, you can multiply by them. And you can multiply and add. Right? That's what we're allowed to do. Add, subtract, multiply, divide. Okay, so let's go ahead and work this out. So I see that we already have that 1 that we want. Now I need to make that a 0. Okay, so you try to think, what can I do? Is there anything I can do to make that a 0? And once you have that 1, it's easy because you need to multiply it by something so that adds a 0. So that something will be -5. So let's go ahead and take row 1 and multiply it by -5, then add it to row 2, and that would be my new row 2. So you can tell yourself what's going to be, what it's equal to. Let's work it out. Row 1 times -5 will give me -5. -1 times -5, +5. And 11 times -5, -55. Let's add it to row 2. Row 2 is 5, -5, and 2. All right, so our new row 2 is going to be 0, 0, and -53. All right, let's see what we have. So if I do that, my row 1 is 1, -1, 11, and my new row 2, we said 0, 0, -53. Ooh, we have one of those special cases. We see that we have 0, 0. Well, that means that we don't have y equal to anything, because we should have this to be a 1, and that to be my y's, right? So this last line, oh, I lost my page. So that last line, we were doing 4. That last line, we can rewrite it to look like this. That would be 0 is equal to -53. Is 0 ever equal to 53? No, right? -53, no. So this is a false statement. When we have a false statement, there's no solution. So this problem is a no solution problem. That's our answer. No solution. All right, so if you like, go ahead and take a picture, a screenshot, so you have the work done for this. So this is 6.3, number 4. All right, and another question was number 6. Let me go ahead and show you number 6.
Ms. Bakari, I
Yes.
had a question.
Yes.
Saying it were to be 0 equals 0, then it would be dependent or consistent.
Yes. Very good. If you were to have that weird case where you have 0 equals 0, then that's a true statement. And that's infinitely many solutions. That's what we say.
And when is it inconsistent?
Well, the solutions that I want you to focus on is if there are infinitely many or there's no solution. That's what I'm looking for. Inconsistent and consistent means it refers to them being no solution and solution, right? So let's take a look back at our notes.
So like number 11, it says inconsistent.
So should be highlighted. It's something that we that it goes attached to the type of solution. It's even in 6.1, I believe. Here you go. So we take a look at the 1, 2, 3, 4, the 5th page in 6.1 notes. 6.1, it gives you a cool little summary of the wording that goes attached to it. So if there's no solution, it's called inconsistent. So that's tied together. And if there are infinitely many solutions, and you say it's dependent.
So all those terms pretty much just mean the same. You could either write inconsistent or no solution, or dependent or infinitely many solutions.
Yeah. I mean, what they refer to when you say inconsistent or when you say dependent, it's referring to the idea that, like for dependent, it's saying that they're overlapping and they depend along this particular rule. And it shows in our notes how there's this rule that we can generalize this at, but I didn't focus on that too much. I just focused on the idea that there's infinitely many solutions, so we have a true statement. Yeah. Or no solution. So if there's infinitely many solutions like we have here, then we can say something like, that's when we have a true statement. And we have an inconsistent system, which is no solution, we have a false statement. And that's what I have been focusing on. The fact that we have a false statement and we say no solution, and that we have a true statement and we say infinitely many solutions. But it's good to know that term that goes tied to it. So again, this is from 6.1, page 5. But this is written in all those 3 sections that we focus on systems. There's an outline that says this exact wording in each section. All right, let's go to number 6. I think we did that one. Let's take a look. Number 6. Yeah, we did that one. So it's another type of question where it's a different type of solution. So same idea, this is also 2 by 2, not 2 by 2, but 2 equations. And we see that we have, we write our equation as a matrix form, and we're keeping our goal in mind. But then along our work, we're left with this type of situation where we're left with a whole row of zeros along with our constant. We shouldn't have a whole row of zeros with a constant. There should be at least 1, 1. So because we're left with 0 equals 0, we see that we have infinitely many solutions because we have a true statement. Sorry, last page again. All right, so here we're at number 6, and we see that we're left with 0 equals 0. And because of that, we have a true statement. So we say infinitely many solutions.
Okay.
All right.
Is it okay if I see 10 real quick also?
Yeah.
Please.
So we did 10 on Wednesday's class. And that was, this is 10. It was a lot of work. If you have any questions about the work, you can let me know and I'll be happy to work with you.
Okay, thank you.
You're welcome.
Professor, can I also request number 8?
8. Yeah, let's take a look at 8.
Thank you.
Yeah. All right, so for 8, we're left with it's 2 variables. Have to stop saying 2 by 2. 2 by 2 means I have a number. I have 2 numbers in the column and 2 numbers in the row. That's what 2 by 2 means. So you have to stop saying 2 by 2. It's not 2 by 2. All right, let's write it as a matrix. My x's, the coefficients are 5, 5. My y's, I keep pressing my arm on the side and I keep losing the page. I'm sorry. And then for my y's, I have 3 and -1. And my constants are 1 and 13. All right, so we know our goal is to have 1, 0, 0, 1 and numbers. All right, so when you make this a 1 and you make this a 0, let's make that happen. So I see that if I make that first row 1, I would have to divide by 5. And if I divide by 5, I would get a fraction. So let's hold off on getting that 1 till the end. But we can for sure work on getting that 0 on the second row. We can make row 2 a 0 by multiplying -1 by row 1, multiplying it by -1, and adding it to row 2, and that would give me my new row 2. All right, let's go ahead and do some work. So row 1 times -1, 5 times -1 is -5, 3 times -1 is -3, and 1 times -1 is -1. Row 2 is 5, -1, and 13. And so we're left with 0, -4, and 12. And that's my new row 2. Let's rewrite our matrix. So we have 5, 3, and 1, 0, -4, and 12. Okay, now we want to get our second column to be 0 and 1. Okay, well, I see I can get that 1 if I'm 1 off, so it wouldn't be so hard. I can get that 4 to be positive. I can multiply my row 2 by +1. I'm sorry, by -1. And that'll make it positive, and then I can subtract row 2 from row 1. So row 2 minus row 1, and that would give my new row 2. All right, so let's multiply by a -1 to row 2. So that'd be 0, 4, and -12. Let's go ahead and subtract row 1. Row 1 is 5, 3, all right. So that would give me -5, 1, and I wasn't done writing. 1, that was row 1. Okay, so I have -5, 1, and -11, and that's my new row 2. So what do we have? We have row 1 is 5, 3, 1. And then row 2, well, we kind of went backwards, 1 and -11. That messed up my 0.
We're subtracting -12 minus 11, minus 1.
I think I messed up. I don't know what's happening. We shouldn't have to backtrack that much. Let's see. So we said we're going to multiply row 2 by -1 to make it a +4. And then we're going to subtract row 1. But then the problem is here because now we undid that. We undid that 0 we worked for. Let's see. Let's take a moment to think. Well, I can add row 1 and row 2, and then I can multiply it by -1, but that wouldn't change anything. I would think I would still have to fix that 0 at the end. All right. So let's go ahead and add row 1 and row 2. Row 1 plus row 2 to get my new row 2. Row 1 is 5, 3, and 1. Row 2 is 0, -4, and 12. We get 5, -1, and 13. Okay, now we're going to multiply row 2 by a -1. And that's going to give us -5, 1, and 13. And that's your new row 2. That's your new row 2. Let's rewrite it. So I have 5, 3, 1. And then I have 5, -5, 1, and 13. Okay, I want to, but you see that does that one. Why am I going in circles? I'm totally missing something here. Well, we have that one. Let's make this a 0. So let's go ahead and take row 2, multiply it by -3, and add it to row 2 to make my new row 1. All right, so we have row 2 times -3 will give me 15. -3 and 13 times -3, -39. Do I mean add it to row 1? Row, add it to row 1. I'm going to try row 1 here. All right, then my row 1 will be 5, 3, and 1. So I have 20, 0, and -38. And we said it's my new row 1. Let's rewrite it. So I have 20, 0, -38. And my row 2 is -5, 1, and 13. All right, so we want 1, 0, 0, 1. All right, lastly, second to lastly, I need to get that 0 in the bottom. To get that 0 in the bottom of the 20, let's multiply row 1 by row 2 by 4. So take row 2, multiply it by 4, and add it to row 1 to get my new row 2. Row 2 times 4 will be -20. Times 4, 1 times 4 will be 4. And 13 times 4 will give us 52. Row 1, I have 20, 0, and -38. So I'm left with 0, 4, and 52 minus 38, 14. So our new matrix is, so this is our new row 2. My row 1 is 20, 0, negative 38. And my row 2 is 0, 4, and 14. All right, I have my zeros. I have to force my ones. So let's divide by 20. And let's divide by 4. I think that's why I'm keep going in circles, because I didn't make that initial one happen to avoid fractions. But now we at least have our zeros, and I have to force those ones. So 20 divided by 20 is 1. You write this in different colors. And it's our final answer. Let's do a purple. So my final answer, 20 divided by 20 is 1. 0 divided by 20 is 0. Negative 38 divided by 20. As a fraction, reduced fraction would be negative 19 over 10. And then I'm left with 0. 4 divided by 4 is 1. And 14 divided by 4 as a fraction is 7.7 over 2. Or you can write a decimal, 3.5. And so those are answers. So this is my x, and it's negative 19 over 10. And for my y, I'm left with 7 over 2. So my answer for x, negative 19 over 10. Or you can write it as a decimal, which is 1.9, negative 1.9. Or y, 7 over 2. Or you can write as a decimal if you're working with a calculator, 3.5. You have to write as a coordinate point. So it'd be negative 19 over 10 and 7 over 2. That's our answer. So here's your problem in case you would like to screenshot it. So you have it handy, you don't have to go through the whole video again.
And for the final, we're gonna have to show all this work.
Yeah, but I might not choose a problem that's this complex. I might do an easier problem. I don't know. All right, let's go ahead and move forward to our review. So I did it kind of late. I'm sorry. The allergies today have been killing me. I posted a review today, and it's half of it. I'm hoping if we do half today and half on Wednesday, it won't seem like too much work, and it'll seem like something we can easily work on and not feel too overwhelmed. Okay, so let's go ahead and move to our review. So I sent you a review. It looks like this. I'm getting you ready for your multiple choice that you might see for your final. And it looks a lot like what you saw for your exam too. Let's go ahead and work through these problems. They're not so bad. There's 7 of them. I'm going to give you 15 of them to review for your final. And I think that would be a good idea of what topics to cover for your final. So let's take a look at that first one. It's asking you to graph the quadratic function using its properties. Based on the graph, determine the domain and range and the quadratic function. All right, so what were the properties for graphing a quadratic? I know it's been a really long time, but for quadratic, we want to know, 1, does it open up or down? Right, that's important. We need to know the vertex, h comma k. And 3, we need to pick more points. We need to pick more points so we can tell how our graph is going to look. Now, it's not written in standard form, but that's okay. If it's not in standard form, I can find the vertex with the formula negative b over 2a for my h. And for my k, I plug that value of negative b over 2a, whatever number it may be, to my function. All right, so taking a look at my parabola, I see that there is a lack of a negative in the beginning, right? There is no negative. So because there is no negative, I can say that it opens up. So I can start answering my questions. For one, I can say it opens up. And that's because there's no negative, right? In the beginning. 2, what is your vertex? Well, we're going to use that formula, that negative b over 2a. All right, what's our b and what's our a? Your b is that number that has the x, so that's my b. And your a is your leading coefficient. So in this case, it's a 1. All right, so that we have negative b, I have negative, and my b is negative 10. 2 times a, my a is 1. So a negative times a negative gives me a positive, so I have 10 over 2, which is 5. All right, so I know that's my h of my hk. To find your k of your hk, you're going to plug in your number. So in this case, we're going to plug in that 5 back into our function. So we're going to find f of 5. If we plug in a 5, I'm left with 5 squared minus 10 times 5 plus 25. Okay, let's work this out. 5 squared, 5 times 5 is 25. Negative 10 times 5, negative 50 plus 25. All right, so 25 plus 25 is 50, and 50 minus 50 is 0. So we're left that our vertex h comma k is 5 comma 0. So we can start graphing it, right? So here we have a graph we can start graphing with. So we're left with 5, 0. And I know it opens up, right? I want to find more points into my function. So I can go ahead and plug in maybe a 7 or a 6 into my function and see what I get. Now we know a parabola has an axis symmetry, right? And it's always x equals your h. So in our case, our axis symmetry is x is equal to, and our h from our vertex is 5. So I know this is going to be a mirror image. So once I find a point on one side of the green line or axis symmetry, I can find another point on the other side that mirrors it. All right, we want to find another point. So how about you plug in a 7 to find another point along our function? Or let's plug in a 6. F of 6. So I'm left with 6 squared minus 10 times 6 plus 25. 6 squared is 36. Negative 10 times 6 is 60 plus 25. You get 1. So I have 6 comma 1 as my next point. 6 up 1. And because of my axis symmetry, it's 1 away from our vertex. 1 away to the left will give me right here another point. If I connect my dots, this is a sketch of my parabola. And if I want more points, I can go ahead and choose more points to work out. All right, which one matches my parabola the best? I think D does, right? Because we have that vertex where we want it. And I think just with the vertex itself, we could have chosen the right answer. So this is how we graph using properties, knowing which direction our parabola opens, our vertex, and more points using the guidance of our vertex.
Did you choose 6 just because it was the next number closest to the 5, like the following point on the x plane?
Exactly.
Okay, that's fine. I want to make sure.
Yeah, good question. because it doesn't make sense to pick a number that's so far away, right? I want to pick something that's relatively close, so I hope that's still within the space I have for my graph.
Yeah, that makes sense. Okay.
Good question. All right, let's take a look at 2. Use synthetic division to perform the division. Wow, I don't think I've said synthetic division since I saw you guys in person. All right, so let's go ahead and work out synthetic division. So synthetic division is using the idea that you have a linear divisor, and we have a linear divisor, right? So when we have a linear divisor, I don't have to perform that long division for polynomials. I can just go ahead and use kind of a trick. Now, synthetic division, we're using the idea that x is equal to a number. X is equal to c. So I can use c for my synthetic division. Now, I'm kind of trying to trick you here because I'm not giving you c directly. I'm giving you x plus c. Or in this case, it's actually always minus, x minus c. So you're supposed to remember that either you're supposed to just use the opposite of the number. So instead of writing 2, you're going to write a -2, or you have to go through the trouble of solving for x. So x plus 2 equal to 0, minus 2 minus 2, x is equal to -2. So my c is 2, -2. All right. Now, what numbers do I use to perform synthetic division? You're going to use the coefficients of your polynomial. So here my coefficients would be 1, -1, and 7, right? But remember, every degree needs to be represented. So because I have a cubic and a square, I need to also have an x, right? A first power polynomial, which I don't have. So I need to rewrite this so that every degree is represented. So let's rewrite this. So I have my x cubed. Next would follow x squared, which I have, minus x squared. And now would be an x, but I don't have an x. So that I don't lose a place value, let's write a 0x plus 7. Now I can go ahead and steal the coefficient for each one. If it doesn't have a leading coefficient, remember it has an invisible one leading it, right? Like we do here. So our coefficients are actually 1, -1, 0, and 7. And those are the coefficients we're going to use to perform our synthetic division. All right, dividing by a -2, I'm going to write 1, -1, 0, and 7. All right, now remember your algorithm for synthetic division, your rule. What's your rule? You bring down your first one, and then you're going to multiply and add, multiply and add, multiply and add until you're done. All right, bring down my 1. Now I'm going to multiply by my outside. -2 times 1 gives me -2. Then I'm going to add. -1 plus -2, -3. -2 times -3, +6. Add, we get 6. -2 times 6, we get -12. And add, and we get 5. Now your last number is always your remainder. If we have a remainder of 0, that means it evenly divides it, and therefore it's a factor. If we don't get a 0, that's okay. It just means that's a remainder. So we have an answer. We were asked to divide. That's our instruction to divide using synthetic division. So remainder is not a problem. So our answer would be,
Is it
Question?
-5? Is it -5?
thank you, yes. It's -5. So let's go ahead and write down our answers. So remember, the last one's a constant followed by one variable, then another variable to the highest degree. It's essentially knocking it down 1 degree. We started with a cubic, our answer is going to be a quadratic, a square. So there's our answer. Answer would be 1x squared, or just x squared, minus 3x plus 6. And we can write plus, and then our remainder, -5. And what do we divide by? X plus 2. Let's see which one matches our answer. X squared minus 3x plus 6 with a -5, that would be B. All right, since that division has been a really long time, are there any questions? All right. Don't forget about the thing about having every degree represented. All right. 3, give all possible rational zeros for the following polynomial. So possible rational zeros are possible maybes. They're maybe my zeros. And I have a list of maybes that I can test using synthetic division. Now, I don't have to test them and find my zeros. I just want a list of all possible rational zeros. Your possible zeros are given by a fraction, right? A fraction of your constant divided by your leading coefficient. So we have to create a list made up of factors of 18 divided by factors of 2. Now I know I have -2, but because we're going to list every single positive and negative, the negative gets worked in regardless. All right, so how many ways can I get 18? I can get 18 from 1 times 18, right? 1 and 18. I can get 18 from 3 times 6 and 2 and 9. I think that's it. How many ways can I get 2? 1 and 2. All right, so I'm going to make division with all these numbers. So all of my zeros will be made up by 1 divided by 1 is 1. 1 divided by 18 is 18. Let me write all that markings. 1 divided by 3. 1 divided by 3 gives me 3. Right? And we're going to do all those numbers. So I have 1, 18, 3, 6, 2, and 9. And then we're going to do that with the 2's. So I have 1 divided by 2 gives me 1/2. 18 divided by 2, well, that gives me 9. I already have 9 listed, so I need to write it twice. Three divided by 2, that would be 3/2. 6 divided by 2, that gives me 3. I already have it listed. 2 divided by 2, that gives me 1. I already have that listed. And 9 divided by 2, that's new. So 9/2. Let me erase all my blue markings. So now I have a list of all my possible rational numbers. Which one matches my list?
B?
I think B does, right? I have 1, 1/2, 2, 3, 3/2, 6, 9, 9/2, and 18. So B would be my answer. Now, I failed to write this. And for every single number, I need to write plus or minus because we're considering the possibility of it being a positive or a negative. They're all plus or minus. All right, let's go on with 4. Find the center and radius of the circle whose graph is shown. Write the standard form of the equation of the circle. All right, so for a circle, my formula comes from x minus h squared plus y minus k squared is equal to r squared. So I need to have 3 pieces. I need to have h, I need to have k, and I need to have my r. All right, well, I have h and k right here, right? H, k. H is 4 and k is 1. Okay, so let's go ahead and plug that into our formula. So that I have x minus 4 squared plus y minus 1 squared. and then r squared. I need to find that radius. I need to find the distance from these 2 points, right? Well, luckily, it hasn't marked for me. And so my distance from one value to the other, well, it's just a matter of counting my x's. From 4 to 10, I have 6 pieces, right? I have 1, 2, 3, 4, 5, 6. So I have a radius of 6. Now, that means I have my radius squared. So that'd be 6 squared, which would be, and change would be 36. So my final answer would be x minus 4 squared plus y minus 1 squared is equal to 36. All right, I think for that one, it would be 4 would be A, have a radius of 6, HK, a center of 4 comma 1, and then it writes that in the correct standard form. So it would be A. Okay, let's take a look at 5. If the function is 1 to 1, find its inverse. If not right, not 1 to 1. Well, this one's really involved. I first have to show A, that it's 1 to 1, and then B, show what the inverse is, if the inverse even exists, right? So let's first show that it's 1 to 1. For a function to be 1 to 1, I need to show that f of A equal to f of B will result in A equal to B. What it does in a graph is it shows that there's only one number for there's only for the x's a number never repeats, and for my y's a number never repeats. But algebraically, without graphing, I would have to show this. Okay, so my function is x cubed minus 8. If I write f of A, that just means instead of x, I'm going to write A. So it'd be A cubed minus 8. And f of B, instead of x, I'll write B. I have B cubed minus 8. All right, let's set both of them equal to each other. So f of A will be A cubed minus 8. F of B would be B cubed minus 8. All right, let's go ahead and solve. If you need an idea of what you want to solve for, say solve for A. So isolate your A. All right, so let's move the 8 plus 8. We get 0. Oops, what happens? We get another 0. All right, so now we're left with A cubed equals B cubed. I want to get A by itself, so let's take the cube root to undo that cubic. So that cubic and that cubic are gone. And oops, that happens again, right? And I say oops, knowing that it's going to happen. So I'm left with A is equal to B, which is what I was supposed to reach, and I reached it. So that we can say, yes, it's 1 to 1. So we can cross off A. A is not an answer because it is 1 to 1. Now, second, I want to find the inverse. Now, to find the inverse, we have a list of steps. First is show that it's 1 to 1, which we've shown. And then 2, or our new step 1, would be to switch your x's and y's. So swap your x's and y's. Then you want to solve for y. And lastly, you want to change your y with the inverse notation. So change y to your inverse notation, f inverse of x. All right, so let's go ahead and find your inverse. All right, so actually I forgot one of the steps. Change f of x to a y. That should be your step 1. So that's 1, 2, 3, and 4. All right, first step, we want to change our f of x to a y. So I have y is equal to x cubed minus 8. Okay, great. Step 2, solve for y. So I want to get y, no, step 2, switch x's and y's. So I have x is equal to y cubed minus 8. Step 3, solve for y. So now I want to solve for y. I want to get y by itself, so I move the 8 plus 8, make it 0, plus 8. I'm left with x plus 8 is equal to y cubed. All right, to finish solving for y, let's take the cube root. Or do to one side, do to the other. And now my cubes cancel. So I'm left with the cube root of x plus 8 is equal to y. And that's my answer. Last piece, I changed to inverse notation. So I'm left with the cube root of x plus 8 is equal to f of x. And we see that one of them matches, right? The cube root of x plus 8, that is C. Any questions on 5? All right, let's go on to 6. We want to graph the rational function. Well, this one's a lot of steps, right? But we have a list of rules to follow. We want to be able to find your intercept. So find x-intercept if we have one. Then you want to find your y-intercept. And then your asymptotes, right? Find your vertical asymptote. And then find your horizontal asymptote. And with the horizontal asymptote, remember to always test it. All right, let's go ahead and get started. So 1, let's find our x-intercept. To find your x-intercept, you're gonna let y be 0. So I have 0 is equal to x minus 3 over x plus 4. All right, let's multiply both sides by our denominator to get rid of it. Anything times 0 is 0, and those are gone. So we're left with 0 is equal to x plus 3. Minus 3, we left with x is equal to, oh, I wrote it wrong halfway, right? It was always a minus 3. So minus 3, so I was plus 3 to both sides. So x is equal to 3. All right, my y-intercept. To find your y-intercept, you let your other variable be 0. So in that case, x. So I have y is equal to 0 plus minus 3. Why do I keep saying plus 3? 0 minus 3 over 0 plus 4. So we're left with y is equal to negative 3 over 4. All right, now our vertical asymptote. To find our vertical asymptote, we're going to let our denominator equal 0. So x plus 4 is equal to 0. You say your denominator equal to 0 to find your vertical asymptote. Minus 4, x is equal to negative 4. Your horizontal asymptote, it's a list of 3 rules, and you can find them in your notes. They're based on the degrees, because this one, they're both of same degree. we take a look at their coefficients. They both have a 1 to be 1 over 1. That would be our horizontal asymptote. So we have a horizontal asymptote at 1. Whenever you have a horizontal asymptote, you test it. You test it by saying it equal to your function. So let's check our test. So I have 1, because that's my horizontal asymptote, is equal to my equation, x minus 3, x plus 4. All right, I multiply both sides by my denominator to get rid of it. So I'm left with x plus 4 is equal to x minus 3. Let's move my x minus x minus x. They're gone now. So I'm left with 4 is equal to negative 3, which is a false statement. So we don't cross horizontal asymptote. All right, so we have all this work, right? Why it's so messy? Okay, so let's find what the vertical asymptote at 4, negative 4. So I have a vertical asymptote at negative 4. I have these two that have a vertical asymptote at negative 4. I have a horizontal asymptote at positive 1. Positive 1. All right, that's the only one that matches. So by process of elimination, we can go ahead and pick B. Now we have more points to graph, right? We also have our x-intercept at 3. So our x-intercept at 3 right here. And our y-intercept at negative 3 over 4, so it's right here. So this one matches our graph, right? And then from there, we know to graph a line that gets closer to our asymptotes but never crosses. And then we'll plot more points to find that we have another graph right here. So B is our answer for number 6. Let's take a look at 7. Solve the equation. Okay, this has to do what we learned our last class meeting. So our goal is to get the same base. Now, as I'm looking at this, I have bases of 4. And here I have a fraction, right? If that fraction bothers me, I can go ahead and write it as a negative exponent. So if I write it as a negative exponent, I can think of this as 4, 3x plus 5, and 256 to negative 1. If that fraction bothers you, you can just get rid of it by writing as a negative 1 with the exponent. All right, so 2 to what power gives me 256? 2 to the 8th power gives me 256, right? So I'm keeping a little side note. 2 to the 8th power gives me 256. And I know 2 squared gives me 4. So let's go ahead and replace those bases. So instead of 4, I'm going to write 2 squared with my exponents of 3x plus 5 is equal to, instead of 256, I'm going to write 2 to the 8th power with my exponent of negative 1. All right, I have the same basis, but let's simplify our exponents. Because I have an exponent raised to an exponent, I have to multiply. So I have to distribute that too. So it's like having 2 with an exponent of 2 times 3x plus 5 is equal to 2, the exponent of 8 times negative 1. All right, let's multiply. I have to distribute. So I have 2 with the exponent of 6x plus 10 is equal to a base of 2 and 8 times negative 1, negative 8. All right, now that I have the same basis, I can ignore them and work with the exponents only. So that I have 6x plus 10 is equal to negative 8. Okay, let's go ahead and solve for x. So then I have minus 10 minus 10. 6x is equal to negative 18. I want to get x by itself, so I divide by 6, divide by 6. X is equal to negative 18 divided by 6, negative 3. And
Would I
that
have
would
been
be,
able to use 4 to the negative fourth power instead of finding basically or
yeah,
simplifying both sides to the 2?
yeah. So he said, hey, so your classmate is saying, hey, isn't 4 to the fourth power 256? So what if I just made this one 4 to negative 4 power and kept that 4? Yep, you could have done that as well and you get the same answer. Good question. Did I answer your question? Is that what you were asking?
Yeah, exactly.
Okay, cool. Thank you so much. And that's right. You could go ahead and do that as well. All right, so this is your first half of your review. Now your review, I'm making it so that it's very similar to your final. So if you didn't see it in your review, I probably won't test it on your final. I'm not trying to trick you. I'm just so happy you stuck through this. I just want to make sure you follow through and do well at the end. All right, so that's it for today's lecture. Do you have an SI session today?
He said no, that he can't make it today.
Okay, so no SI session? All righty. I don't blame him. I had really bad allergies. I was so close to canceling class. It's just not doesn't feel good today. I just have a constant headache. But I was like, no, I can't let them down. I would feel so bad if you thought I'll eat down right before finals. So I'm here. If you have any questions, feel free to email me. But that's it for today. If you have any questions on the first part review, you can email me or you can check out the video. I'll post it hopefully within 2 hours so you can review these questions over again if you feel like you need to. All right, well, that's it for today. You're welcome.
Thank you.
Thank
And
you
then
so much.
test
Yeah.
3 review for extra credit is due tonight, right?
Yep, your test 3 is due tonight and so is your review.
Okay.
So if you haven't taken your test, make sure you do it before end of day today. Thank you for reminding me. I meant to remind you guys. All right, so have a nice day. Make sure you take your tests if you haven't done so already and turn in that review so you get those extra credit points added to your exam. Thanks.
And the online homework as well, right?
Online homework, you have
book?
until, yes. You can turn in this Tuesday for full credit, but if you're falling behind, everything's open until the end of the semester, so I put it until Monday. So make sure you get it in by latest a week from now.
Okay, thank you.
Well, thank you so much for being here. I'll see you on Wednesday. Let me know if you have questions.
See you Wednesday, Professor.
All right,
Thank you.
thank you.
Bye.
Bye.
Thank you, Professor.
Welcome. Thank you.